So today we'll be talking about constant acceleration. Now acceleration is a change in velocity over time, and you can accelerate when you change your speed or change your direction. However, our focus is constant velocity and acceleration, so there's no change in speed and no change in direction. Some involved variables include your initial velocity and your find. Now, these both include meters per second, that is the unit that we use when we're talking about velocity. And velocity, keep in mind, is also a vector, so it does involve a change in direction. Now, time, acceleration, and your vertical distance is what our focus is on also down here. Time, that's your symbol for time, is t. A, acceleration, which is also meters per second squared. Your vertical distance, dy. And moving on, so applicable formulas, we have these. You can see, just look at those and keep those in mind. All right, so our example problem: a rock is dropped off a bridge and hits the water 3.20 seconds later. How tall was the bridge? Now this is our bridge. You see the little cars that I drew. I know it's so nice. Okay, so we're focusing on our vertical distance. This is the rock, this is the water. And now our question is, do you think gravity will have an important role in this? Because we want you to be thinking about this. And your answer is yes. Now let's think about our givens. Time, 3.27 seconds. Gravity, now we know that it's included, and we know that gravity is 9.8 meters per second. Now the best equation for this is your vertical distance, dy, is 1/2 your gravity times time. Okay? Now, we're going to plug that in. Alrighty then. See my little play on illustration. See that? Plug it in. Yes. Okay. Okay, so vertical distance is your 1/2, 9.8 meters per second, times your time, 3.27 seconds squared. That is squared. Alright. Where are you? So, here we have it again. The bridge, the rock, time, and we do not have vertical distance, and this is how we're going to find it. We're going to plug in what we do have into the equation. We have gravity, so we have 1/2, or if that freaks you out, 0.5, times 9.8 times 3.27 seconds squared. Remember that? Squared. Okay, so when we do all the math, your answer should be 52.4 meters. That's the distance from the bridge to the water. And that's it.